Okay, good morning class. So today we're looking at geometry. We must do page 20. Is that correct? Okay, so we're on page 20. So in this lesson we'll do page 20 and probably 21. So you have to do both homework, no? Alright. Make sure that goes off. Okay. So here we are told to prove that triangle ABC is congruent to triangle DEF. Let's prove congruency here. So where do we start? We can say in triangle. Let's sort this out together. We can say in triangle ABC and triangle DEF. So what can we say? We know that angle B is equal to angle E, which is equal to 35 degrees. Why? Okay. Then we know that angle C is equal to angle F, which is equal to 70. Why? Given. And then we know that the length AB is equal to DE, which is equal to 35 centimeters. Why? So this is enough information to conclude congruency, not so? So therefore triangle ABC is congruent to triangle DEF. Why? Angle, side. Now, in the next question, in this number 2, they ask why is AC equal to DF? And why is that the case? AC is equal to DF. AC is equal to DF. Why? Because we have proven that triangle ABC is congruent to triangle DEF. Okay? So any confusion there? Alright. Let's go with B. Just let me know when the page changes, okay? I must change the number. Again, they asked to prove that triangle ABC is congruent to triangle EDC. Right. So we say for number 1 is in triangle ABC and triangle EDC. So it's, what can we say about the two triangles? We can say that AC is equal to CE, is equal to 39. Why? Given. And then AB is equal to ED. Why? Which is equal to 52 degree, 52 centimeters. Why? Given. And then BC is equal to DC, which is equal to 53 degrees. Why? 53 centimeters. Therefore, triangle ABC is congruent to triangle. So we've got A going through the 52 and then the 53. So the order of this has to be through the 52. No. So it's E, D, C. So the order is correct. And what account is that? Side, side, side. You all agree with that? What can we say now? In number 2. Sorry, what? Okay, so the question is, why is angle B is equal to angle D? So as you can see, it is on the right place. The angle B is equal to angle DY. Because triangle ABC is congruent to triangle ED. So again, in the exam, if you haven't proven that triangle is congruent to that triangle, you can still answer the next question stating that it's congruent. Okay? We'll do that as well. Let's go to number to C. And C, we are asked to prove that triangle ABC is congruent to. So we say in triangle ABC and triangle EDC. What can we say? Did we do this one? No. So what can we say? AB is equal to ED. Why? Why is that equal? It's given. Alright. Then BC is equal to CD, which is equal to 53. Why? Given. Then angle B is equal to angle D, which is equal to 35 degrees. Why? So therefore, it's not number one. Therefore, triangle ABC is congruent to triangle. So you got ABC has to be EDC, which is the correct order there. And what's the count for congruency there? Side angle side. Remember, when we use side angle side, it must be the included angle. The two known sides and included angle. Okay. Okay, number 2. Why is angle C1 equal to C2? You look here. C is on the side for the correct place. So angle C1 is equal to angle C2. And the reason here is because triangle ABC is congruent to triangle EDC. Okay. E. Okay, E asks us to prove that those two triangles are congruent. So we start off by labeling the triangle we're working with. So in triangle ADB and triangle CDB. People, the order that is given initially or normally is the right order. Okay. So what can we say? That AD is equal to DC. Why? Given. As you can see, those lengths are equal. Then D1 is equal to D2. Why is D1 equal to D2? Those are given to us. Not so. As you can see, both has dots in it, which means to say they are the same. DC is a common side. So we have 3 points there. Okay, as you can see, the DC is in both triangles. Okay. So we can conclude therefore triangle ADB is congruent to triangle. So you got ADB, it must be CDB. Yeah?
It's DB that's the correct.
Oh, DB. Okay. Thank you. So it's going to be CDB, and the reason is side angle. Thank you. Man. Again, you can see it's the included angle. Okay. Number 2. Why is AB equal to BC? AB is equal to BC. Why? Because triangle remember that AD is equal to CD. DB is equal to DB, which we know, and AB is equal to CD. Once you have proven congruency. Okay, so, and the reason why that is the case is because triangle ADB is congruent to triangle CDB. Okay. Then number 3, I'll show that ADC is perpendicular, which means to say that is 90 degrees in other words. But we already said that D1 and D2 is equal, not so. Why are they equal? So it was given to us. So we know that D1 plus D2 is equal to 180 degrees. Why does this add up to 180? Because this angle's on a straight line. Okay. So now, if D1 is equal to D2, why is that the case? It's proven or it was given. Okay? So which means to say D1 or D2 can be replaced with the other. Okay? So but I'm not going to replace D1 with D2 and D2 with D1. Then I'm back at square one. So I replace D2 with D1. So it's D1 plus D1 is equal to 180. So double D1 or twice D1 is equal to 180, which makes D1 equals 90 degrees. Can you see that? So if D1 is 90, which is equal to D2, which is 90, then this has to be perpendicular. Can you see that, people? So I can conclude, therefore ADC is perpendicular to DB. I think it was that, no? ADC, yeah, is perpendicular to BD. Okay. Why? Because why that angle is of course 90. We're still on page 21. Okay. If we are told that ABC is a kite. Now there are properties for kites. Okay, we know that. I know yesterday you guys have written all the rules down, but for properties of a kite, I think there's 5. I think. Okay, but it says prove that triangle ADC is congruent to triangle ABC. Use 2 different methods. Okay, we will just do it. Alright, I'll just name that. So, where do we start? We say in triangle ADC and triangle ABC. Where do we start? We say then that AC is a common side. Why? Because it's in both triangles. It's triangle DAC and triangle BCA. What else do we know? We know that CD is equal to CB. Why? Because 2 pairs of adjacent sides are equal. 2 pairs of adjacent sides are equal, which make those equal to that. Then AD is also equal to AB. Why is AD equal to AB? Because of 2 pairs of adjacent sides equal in a kite. It's supposed to say in kite. Okay. So what do we have here? We have enough to conclude congruency here. Not so. It is side, side, side. So therefore triangle ADC is congruent to triangle ABC. Why? Side, side, side. Okay, that is one way. Alternatively, I could have said, firstly, that is equal to that. That is equal to that. So I keep those two. However, I say that angle D is equal to angle B. Why? Because our one pair of opposite sides are equal in a kite. And in what case of congruency would this have been? Side, angle, side. Okay? This is another way I could have approached this. This is another way. You could have gone and kept this. You kept that. No. You keep this one, you go with that one, and this one. We go with this here, which is your common side. Okay? And then we say that angle C1 is equal to angle C2. Why? C1 is equal to C2, and the reason is your diagonal bisect the vertex angle in a kite. In what case of congruency would that have been? Side, angle, side. So there's three different ways. I could have gone this way as well. If I had kept that, I kept gone with that one there. So AD is equal to AB. AC is a common side. And then A1 is equal to A2. Diagonal bisect one vertex angle in a kite, and it would have also been side angle side. Okay, so there's four different ways of doing exactly the same. Okay, we're still on page 21. So it's now on page 22. Okay, there's a lot of sums on page 21. Right, G. Right, so here we are told that AB is parallel to CD. People, if AB is parallel to DE, not BC, DE, then we know that alternate angles are equal, so angle E is equal to angle D, alternate angles, as well as angle D. Angle E is equal to angle A, alternate angles, and angle D is equal to angle B, alternate angles. Okay. Then we are told that BD bisect AE. Bisect means to cut it off. Okay, so that is off. Prove that triangle ABC is congruent to triangle EDC. So where do we start? We start by saying in triangle ABC and triangle EDC. So what can we say? Start with what they told us. So AC is equal to CE. Why? Give it. Alright. Now we know that C1 is equal to C2. Why is C1 equal to C2? Vertically opposite angles. Vertically opposite. And then angle E is equal to angle A. Why is angle E equal to angle A? Because of alternate angles. Alternate angles with DE being parallel to AB. So that's enough to conclude congruency. Not so. In what case of congruency is this? Angle, angle, side. So it's it's triangle. So therefore triangle ABC is congruent to triangle. So we go ABC. It must be EDC, which is the right order there. EDC, and what the count of congruency is? What case? Angle, angle, side. Let's look at number 2. Number 2 says to show that AE bisect BD. Which means to say, you must show that A is cutting BD in half. Okay, or in other words, we must show that DC is equal to CB. But if you look at this case here, DC is equal to BC. Not so. And that's what we needed to prove. So we say since, state the obvious, since BC is equal to DC. Why are they equal? Because triangle ABC is congruent to triangle EDC. Because that is the case. Okay, so they are equal now. So therefore, we answer the question AE bisect, which means cut in half, BD. Okay. Let's go to the next question. H. We're still on page 22. Okay. There's a U here. Okay. So we are told that PQRS is a parallelogram. So if PQR is a parallelogram, since you guys have listened to the parallelogram rules, what are the rules? There are 4 of them. Okay. What are the rules? Opposite sides are parallel. That's rule number 1. Then opposite angles are equal. That's number 2. That is, she's saying interior angles adds up to 360. That is the rule for all quads. Okay. Another one. Opposite sides are equal. Last one. Diagonals bisect each other, which means you say the diagonals cut each other in half. Okay. Let's go with that. So that's a parallelogram. And TQ, so this is a rectangle. People, if this is a rectangle, there are 5 properties. What are the properties of a rectangle? Opposite sides are parallel, number 1. Opposite sides are equal, number 2. Diagonals are equal in length, number 3. Diagonals bisect each other equally, number 4. The 5th one is that all vertex angles are 90 degrees. So when they tell you something's a rectangle, all that properties are evident there. They tell you something's a rhombus, or in this case a parallelogram, then all 4 properties of a parallelogram is evident there. They don't have to write all of those things on the diagram. Okay? So that's it. You're asked to prove that triangle PQS is congruent to RSQ. So let's go. In triangle PQS and triangle RSQ. So PQS and RSQ. RSQ. So what do we know? We already said that opposite sides are equal. Not so. So that is equal in that parallelogram, and that is equal in that parallelogram. Not so. What else do we know? Opposite angles are equal in the parallelogram. Or we could have said that SQ is your common side. So any one of the 2 is going to be correct. However, if I'm going to use that to be a common side, then it must be side, side, side. I can't use that as a common side and say side, angle, side. I'm not going to lose the reason mark. Okay? Any confusion? Alright, so let's go. So we are saying in triangle PQS and RSQ, we are saying firstly that SQ is a common side. Okay, and then PS is equal to QR. PS is equal to QR. Why? Because two pairs of opposite sides equal in parallelogram. It's another way of writing a parallelogram. We can write that, the word parallelogram or PAR. Okay? Then we know that RS is equal to PQ. So PQ is equal to RS. Why? Because two pairs of opposite sides equal in a parallelogram. So that's enough to conclude congruency, not so. So we can say therefore triangle PQS is congruent to triangle RSQ. Why? Because side. Alright, let's look at number 2. Yes? Yes? So if you're going with alternate angle, so you're saying that S1 is equal to Q3. Is that what you said? But did you first say that PS, so your approach should have firstly been PS is parallel to QR. Why? Because two pairs of opposite sides parallel in parallelogram. That's number 1. Then you had to say that S1 is equal to Q3. Why? Alternate angles with PS being parallel to Q. Did you say this? So you put this with that? Okay, no, that's fine. Because this, we didn't qualify it to be parallel yet. So that's why I say you have to say this. But if you had said that as part of this reason, then you would have gotten the full mark. So your reason would have been side, angle, side. So you went another angle here.
No, I went this way.
Oh, okay. So you went that way as well. So you got that to be equal to that. Nice. So you use angle, angle, side. Which side did you use QS? Yeah, angle, angle, side. Nice. But otherwise, if you had gone with that being common, this being equal to that, and that angle there, then it would have been side, angle, side. Can you see that? So there's many ways of proving congruency in this case. And then in number 2, they ask you to prove that triangle. So I'm not going to, as you can see, there's not much space here. So we're going to go straight into this here. So they ask you to prove that triangle PTQ. Okay, I'm just going to take this off for a while. And then just write it out neatly. Just remember now that those two triangles are congruent. So I can use the fact that they are congruent in the next calculation if needed. It looks like I would need it anyway. So in number 2, we're going to say in triangle PTQ and triangle RUS. So PTQ and RUS. Okay. So we know already that this is 90. We have spoken about that already. Not so. What else do we know? We know that this length here is equal to that length. Not so. Why? It's a rectangle. Opposite sides are equal in the rectangle. We need one more, either side or angle. We need one more side or one angle. Is it not evident that PQ is equal to SR? Why? Proven. Not given, proven. We used that in the previous calculation. And we gave its reason. So it's either we say again that PQ is equal to SRY, two pairs of opposite sides are equal in a parallelogram. We either state the full theorem or we say proven above. Okay. So there we have side 90. So that is R. Are we using the hypotenuse? Yes. So it's going to be RHS, the case of right hand hypotenuse side. Alright, so let's go with it. So we're firstly going to say that angle T is equal to angle U, which is equal to 90 degrees. Why? Vertex angles equal 90 degrees in rectangle. Vertex angles equal 90 degrees in the rectangle. So I put 90 there, 90 here. Then we know that TQ is equal to SU. TQ is equal to SU. Why? Because quad TQ TSUQ is a, no, they told you it's a rectangle. So we're going to say that's equal one. So two pairs of opposite sides equal in the rectangle. Okay. And then we say that PQ is equal to SR. Why? Because we already proved that triangle PQS is congruent to triangle R is Q. Okay, we could have said proven above, as I just said earlier. People, that's enough to conclude congruency, so therefore triangle PTQ is congruent to triangle RUS. Why? Because it's the case of right hand hypotenuse side. As you can see, you use the 90 degrees and the hypotenuse. Okay? Any confusion here? You still on page 22? What else did I give you for homework? Sorry? I only gave you those two. I'll give you now another 2 pages for tomorrow. I'll stop the video at this point.